Welcome back, Math 30-1. So we're going to continue our second part of composition of functions here. You're going to ask us to evaluate A and B here. The same way we did before, really. You just do one and then you do the other. And then down here, it doesn't look like we're evaluating. We're just making a new function. As we do that, maybe we can actually make a new function and think about the domain and range. Why not? All right, so this one here, all this is saying, and I'm going to say f of g of 3. So what it's actually saying is I'm going to do a substitution within a substitution. So I'm going to substitute 3 into g of x. So I'm just going to write this out. 5 times 3 minus 9. So that's what 3 into g of x looks like. And I can just simplify that down just a little bit. 15 minus 9, 6. Okay. And then I'm going to take that 6, I'm going to put that into f. So that's going to look like 2 times 6 squared minus 3 times 6 plus 3. So I'm just going to punch that in my calculator. I got it right here. 2 times 6 squared minus 3 times 6 plus 1. Okay, so I get 55. So that's how you evaluate these. You just go step by step. Now, if you have 3 here, this is just saying g of h of 2. So you're just going to do this a few times. So h of x, you can see h of x here is just x. So if I put 2 in, I get 2 out. Okay, so that's going to end up being g of 2. Okay, then I'm going to put 2 into g, and g over here is 5x minus 9. So I'm just going to write that out. So 5 times 2 minus 9. So I'm just going to simplify that down. That's 10 minus 9, so that's going to be a 1. Okay. And, yep, then I'm going to do g of 1. So that's just going to be 5 times 1 times negative 9. Or minus 9, sorry. So 5 minus 9 is negative 4. So that's essentially how you evaluate it. You just go step by step, working your way from the inside, outside, kind of like how we did our domain. So and the same thing down this graph down here. Well, I'm just going to make this one here. So I'm going to put f into g. So f is this big thing here, 2x squared minus 3x plus 1. I'm going to put that into g. And here I'm just going to put g, because that's all it is. I put x into x. It's just the same thing. Now here I'm going to replace all the x's in g of x with this big thing. So g of x is 5x, but now it's 5 times x squared minus 3x plus 1. And then I'm going to add 5x minus 9. I got rid of the parentheses there because it's just a positive in front. There's nothing there. But I'm going to have to multiply the 5 in to get rid of these parentheses. So 10x squared minus 15x plus 5 plus 5x minus 9. So your 10x squared minus 10x minus 4 as my final equation. Let's just call that h of x again. Just give these names. I didn't bother giving these ones names. Okay, so technically you could do that and then just say, okay, now let's put in x equal to 2 and then get my final answer. You could have done that with any of these. I think it's just easier if they give you the number, just go step by step rather than trying to create a new equation and then putting the number in. I think it's up to you. So you could have done this exact same thing and now said, okay, now what is h of 3? So rather than putting 3's in and calculating them here, I can put the 3's down here and calculate that. If I wanted to, I don't have to in this case. Okay, so we're going to do the same thing. We're going to evaluate these, but this time we're going to use graphs, and they're a little bit trickier this time. Essentially the same idea, what we just did. So we're going to do f of g of 1. Okay, so I'm going to first of all find out what g of 1 is. So g of 1. So I'm going to go over here, find out my x value is 1, go down to g, and then read its y value. So its y value of g at 1 is negative 3. Okay, now what I'm going to do is go find negative 3 is my new x value. Go up, and then go over to 1. So my answer for this would be 1. Okay? Now here we're going to do g of 5. So I'm going to find 5, my x value of 5, so it's over here. I'm going to read my x value. You can see that's a 1. So I'm going to replace that. right there. And then I'm going to do g of 1, which we already did before. G of 1 is negative 3. There you go. Interesting, right? So we use the answer from 1 as the x value for the next one, and then we just continue around. Okay. We're going to state the composition of these functions here. Maybe evaluate, like this last one here just asks us to evaluate, or this one's asked us to evaluate. Here we're going to create the functions, or we're going to evaluate that too. Okay, so here I'm going to create the functions. If I'm creating the function, I'm going to state the domain. It says up here, state the domain as well. So this just says f of g of x. So that means I'm replacing all the x's in f. F is 4x. I'm replacing that with whatever g of x. I'm taking this one here and putting it into that one over there. So it would be, well, actually, I'm just going to write it out first. F of x plus 6. That's going to turn to 4 times x plus 6. And then I have 4x plus 24. If I did my math correctly. So there's my equation for that one. Yeah, so let's go through our domain. So the domain of this before I plugged it in was XER. My final answer was XER. So my domain is XER. So nothing really shocking there. Now, because this is the same thing, this is f of g of x, and this is f of g of negative 2, I could do it the same way that we did it previously, or I can just use this equation that we have here. We decided this equation was 4x plus 24. So I can put a negative 2 into that equation. And I don't know why I'm pulling the calculator, but I might as well get 16 there. Okay, so my answer is 16. But if I try this the other way, remember what we did before, f of g of negative 2, I can first of all calculate what g of negative 2 is. So g of negative 2, g is 6. X plus 6 is negative 2 plus 6. That would be f of 4. And then I can put 4 into f. That'd be 4 times 4. I get 16. So it works out the same way both ways. Awesome. Okay. So now what we're going to do for the next one here, we're going to just put h into f. So where's f? F is that one. Okay, but first of all, before I do that, I'm just going to put what h is here, because that's an important step. Because this is going to be important to determine what is my domain, because I want to know what the domain of this is before I do all the simplifying part. But now I'm going to put that into f. That's before times this. And I'm going to look at the domain of both of these functions, the simplified one and then the not simplified one, but they both end up being the same. Because I'm really just worried about what's underneath the square root for both of these. So this x plus 5 has to be greater than or equal to 0. So that means x has to be greater than negative 5. They both have that same domain. So that means my domain has to be that number. Okay, x here. I'm having fun with this rainbow pen. You can leave me a comment if you don't like it or not. Okay. Yeah, that's it for that one. This one here is just evaluating. You just want to put a 0 into this. So you're going to go h of f of g of 0. So what is g of 0? So g of 0, let's put it over here actually. That thing's going crazy on me right now. Okay. H of f of g of 0, so that's 0 plus 6. So that's just h of f of 6. Okay. Now f of 6, so f of 6 is 4 times 6. So that's 24. And then h of 24, let's put that in there. H of 24, 24 plus 29. The square root of 29. That looks pretty good. I guess that's the way it is. You could actually create the equation first. You can put g into f and then put that into the other equation. It should end up being the same thing here. Okay. Okay. So let's see what we have here for the next page. well, we've done this before. I want you guys to try this out. Give me a good bit of pause. Try out to fill out this piece. You don't necessarily have to graph it if you don't need to, but we can do our domain and ranges and what the equation are. So I'll give you a little bit of time to do that. Okay, hopefully that was enough time, and we can pause these videos. Okay, so I'm going to put in this one here, I'm going to go f of g of x. That means I'm putting g into f. So I'm just going to replace g, first of all, with x squared. And then I'm going to replace all the x's in f with x squared, and then I'm going to plus 1. So this equation just turns out to be x squared plus 1. Now the domain of this before I started was xer. The domain of this last graph is xer. So my overall domain is xer. Because what we know this already, this I can look at this graph right now and tell you that the domain of, or the range of this graph is y has to be greater than or equal to 1. That's just a quadratic, not too bad, pretty easy to do. You can graph this out. It looks something like this if you wanted to do that. All right, x and y. Okay, cool. And this one, you're doing the other way around, so we're going g. We're going to put f into g here, so g of f of x, or g of f of x. Yep, that's right. So I'm going to replace what f of x is. So that's just x plus 1. And then I'm going to replace where is an x with x plus 1 in g. There you go. I'm going to square that. It gets x squared plus 2x plus 1. Okay. Now that graph will look like this. Right? Just horizontal translation to the left. All right, this was a vertical translation upwards. I still have xer, because both those equations are xer in the first place. And my domain is going to be greater than 0 this time. Oh, my range, sorry. There you go. Oh, this is a fun one. Just kind of reversing the operation. You think, okay, imagine fx was, or sorry, h of x was f of g of x. Okay, so now we wanted to kind of determine what solutions, what could f and g be if I wanted to create this equation. There's always lots of easy or hard ones. There's an infinite number of these answers that can actually produce this. But just usually the easiest one is thinking, okay, what's common here? So I'm looking at this and I'm looking at this. These two pieces are common. So what if one of my functions, the one I put into the other, say, imagine that g of x was that common piece. Okay, so now let's say I took that common piece out. I took this piece out here, I took this piece out here. What if I just replace them back with an x? What do I get? Well, I get x squared plus x plus 1. Let's just say that's f of x. So now if we kind of reverse the operation, do I get this back? Do I get this h of x back if I do f of g of x? So if I did that, I would have this situation where I'd replace all the x's with x minus 2. Yeah, I'd get that same thing back, and that looks about right. Okay, so there's lots and lots of different answers. Like this one, I can have multiple answers, like multiple easy answers. You could say, okay, maybe my original function was, this x here, was the root of x plus 1. How do I change that x into x plus 1? Well, I replace it with an x, or sorry, how do I replace an x into an x cubed? I replace it with an x cubed. So if I put this one into that one, it changes to an x cubed. You replace the x's. You're not multiplying them, you're not dividing, you're replacing it. So the x just becomes an x cubed. Or maybe my original function was just the root of x. How do I change that to be the root of x cubed plus 1? Well, I replace that x with an x plus 1, or x cubed plus 1. There's another one. I'm sure there's other answers, but these are the two easiest ones. Okay, and there you go. So you're just kind of reversing the operation. You're just trying to think, okay, how do I get this answer? How do I get this piece here using two other pieces? Yeah, that's all you really do. Yeah, okay, I'm going to do this page on this video here, then maybe cut this one here. I'm going to give you a little bit of time, because I want you to try to figure out what are the two functions, f and g, so that if I put g into f, I'd get what you see here. Okay. Go. Okay, so hopefully that was enough time. You guys paused, you can make whatever time you want. Unless you could have went and got cookies or made some coffee or tea or something. All right, it's up to you. So that's in common there. So it seems like my original function, if I get rid of these yellow pieces, my original function kind of looked like x cubed plus x minus 2. But how do I change it so that they have these roots in there? Well, I replace all the x's here with x, the root of x plus 1. That seems like that's what you would have to do. Yeah, there you go. Now you can do the same thing with the other operations, where they kind of give you what the answer is, and then they tell you, okay, what if I multiply these two together? What could they be to get the same step? Those are the nice, you can just kind of rearrange the equations. Like if I said, okay, h of x is equal to f of g times g of x, I could just say, okay, I'll just divide f of x over. And I can find out what g of x is. I could do that with this kind of operations when you're multiplying or you're dividing or you're adding, subtracting. I'm allowed to just rearrange the equation if I want to. For composition, you can't really rearrange the equation. You have to kind of think about it to figure out how could I do this. It's more of a logic kind of thing. So this is just a little side note. You're allowed to rearrange these other composite or these other functions, these other operations, but you can't rearrange this one. You just have to think about them. Okay. Same thing with this one. Try it out. I'm gonna pause. Okay. So hopefully you tried it out. So I want to know what f of x and I want to know what g of x is. So I'm putting g into f. So I'm going to look at this and say, okay, what do they have in common here? Well, we have this piece and we have this piece. Those look like they're in common. So maybe f of x, if I just get rid of those two pieces, it'd be x plus 3. Maybe that's what my original function looks like. And then if I want to change it into this one, I can say that. So I can replace all those x's with the cubed root of x. And I'm done. I'm good. I like this next question. Let's finish off this video here on this question here. Because of what these are. Like this is a log base x, a log base 5 of x, sorry, and this is a 5 to the power of x. What I know about these two functions is that they are inverses of each other. Okay? So you're going to see something key that if you put an inverse into itself, not into its like self, but you put a function into its inverse or the other way around, you get something out. Let's just look at this one here. So I'm going to put g of x, I'm going to put this 5 to the power of x into f of x. So I'm going to go log base 5, I'm going to put 5 to the power of x here. What I'm going to do is I'm going to use my log law. So this exponent here is going to drop down in front. I'm going to get log base 5 of 5. And remember your rules. Log base 5 of 5. Log base 5 of 5 is 1. So I end up with just an x that kind of pops out. Okay, so I got an x out. Let's try this other one over here. So what I'm going to do with this one is I'm going to put the other guy, the log of x, into the g of x. So that means I'm going to replace all the x's in g of x, but my x is in my exponent with log base 5 of x. Okay, this is a bit trickier to do. Remember, there is the law here. What I know about this is it should just end up being x. It should end up being x. So what I'm going to do is I'm going to make it equal to 5, and I'm going to change this into exponential form, or into log form. So what this says, if I go change this into log form, this is going to be log base 5 of y is equal to, because it's equal to y, that's what I want to know. What is this? That's in here now. For some reason, I put it back into the log, and I'm going to drop down that exponent. Oh, log base 5 of y is equal to log base 5 of x. That means y has to be x. That means this up here has to be x. So that's good. So if this is what happens, if I put one into the other and I put the other into the other, into the one, I guess, okay. If I get x out, this indicates that these are inverses of each other. And this works for all inverses, right? So think about x squared as 1. The inverse of x squared is the root of x. If I put 1 into the other, if I put 1 into this one, make my new equation, I get x out. Or if I put it the other way, if I put, and I square it, I get x out. So these are inverses of each other. Other ones would be like, what's g of x if that's 1 over x? The inverse of 1 over x is 1 over x. It's a very fun, it's an inverse of itself. So if I put 1 into this one here, 1 over x, that's going to flip over, that's going to turn to x. Or if I go the other way, it's just the exact same math, I get x. So those are inverses of each other. So if they're inverses of each other, if I put 1 into the other, I should get 1. Or sorry, I should get x, not 1. My bad. I should get an x. So that indicates make sure that tells you that's an inverse. So if you want to test something, see is it actually an inverse, you put that back into the original equation, and it should get out the variable that you originally put in. So you get x back out. That's a really good way to determine if something is an inverse, or just to verify. Okay. The next video, we're just going to stop that video. I'm going to talk about more about these graphs. We're going to evaluate them. You should be able to do these now. These are all questions we should be able to do. H of x is a bit weird because they have this cotangent squared thing here. We'll talk about that in a bit. But the rest of these you should be able to do, and we'll talk about the answers. I want you to try them out first. I'll see you in the next video. Bye.